You wonderful Earth Science kids. This is another episode of Yo at Home, and I'm going to be talking about a concept we need to understand, and that is insolation. Insolation is incoming solar radiation. Insolation. This is not the stuff you put in your attic to keep your house warm. This is simply sunlight. It's that sciencey term for sunlight. Okay, now we could talk about a variety of things with insolation, but right now what we're talking about is really why do we have summer and winter? And if you think about the sun being here and the Earth on its axis, tipped towards the sun in the summertime, as we go around the sun, 6 months later we're now tipped away from the sun. Simple enough. We name the places where the sun can be overhead, the edges of those places. These are called the tropics. Now, you would think of the word tropics as being warm and moist, humid, all that. Yeah, that's what the tropics are like. And the tropics are within these two bands. Because the Earth is tipped 23.5 degrees on its axis, we go up to 23.5 degrees north to 23.5 degrees south. In the summertime, the sun is overhead, at least on June 21st, 23.5 degrees. Okay? New York State is roughly 42 degrees latitude. So this is the Tropic of Cancer, and that is where the sun is directly overhead on June 21st. Question is, how far, how many degrees are we from where the sun is directly overhead? The sun being directly overhead would be 90 degrees overhead. If we were 1 degree away from there, you realize the sun would be 89 degrees overhead. Well, we're not 1 degree, we're 19 degrees. So if we look at that, 42 minus 23 degrees, it's 19 degrees. If we take that 19 degrees away from the sun being directly overhead, that gives us 71 degrees. That's how high the sun is in our sky on the summer solstice, June 21st. If we look at 6 months later, now the sun is over here, overhead, 23.5 degrees south. I've just been rounding it to 23 degrees, which is fine. This is the Tropic of Capricorn. So how far are we from there? Well, we're 42 degrees from the equator already, plus another 23 degrees to get down to the Tropic of Capricorn. So 42 degrees plus 23 degrees, we are 65 degrees away from where the sun is directly overhead. If I take 90 degrees and subtract 65 degrees, that gives us a sun angle of 25 degrees on December 21st. And this is what that looks like. So the summertime sun angle, it feels like it's directly overhead. Please notice the sun in New York State is never directly overhead. Where can you find a place where the sun is directly overhead? Like I was saying, inside the tropics. These are places where the sun can in fact be directly overhead. New York State, well, it feels pretty close. It's not that close, with 71 degrees. But over the year, from June 21st, June, July, August, September, October, November, December, by the time you get to December 21st, 6 months later, this is the maximum elevation of the sun. And think about it. On those days in late December, the sun comes up, it gets up late in the morning, sets early in the afternoon, and it never gets very high in the sky at all. So, what's the difference then? Well, when the sun is directly overhead, it warms you up fast. A lot of its heat is directly onto the ground, and it heats it up. This time of the year, the heat is spread out over a much larger area when it hits at that low angle, and it doesn't warm us up very much. So right here, changing altitude of insolation from June 21st to December 21st, by changing the altitude of insolation, we radically change how much heat we're given. That is one of the major reasons why we have summer and winter. The other reason has to do with, if this was a line pointing east to west here, when you have summertime, the sun rises 23 degrees north of that, and the sun has to climb all the way up to get to 71 degrees in the sky, and then it has to climb all the way back down to set in the western sky. In winter, the sun is rising 23 degrees south of that line. So it just has to climb up to here and climb back down to there again. It doesn't take very long to move through that, whereas it takes a long time to move through this. Remember how fast the sun moves through the sky per hour? The sun moves 15 degrees per hour. So you can tell in the summertime, this is going to be a very long day, getting the sun all from here all the way up to here and back down again. In the winter day, it doesn't take very long at all for the sun to rise, come up to here, and then set again. 15 degrees per hour, summer and winter, but in the wintertime we have a lot less hours of daylight, and all the hours we do have, the angle of insolation is much, much lower. So this explains the seasons rather neatly, doesn't it? Thanks for watching.